Hi, this is my submission for the ML project, Module 5. So starting at the top, from an opportunity evaluation perspective, defining the problem, I've identified the target user, the problem statement, why it matters, and what is the current state of the system. So from the top, again, the target user for this project would be a customer care agent or a retention agent. And the problem we're trying to solve is today need to decide in advance if a customer calling in or asking for cancellation is a low risk customer or a high risk customer. And if the low risk customer, the customer needs to be retained even if they miss a few payments. Why it matters is because a lost customer is a loss of revenue, and if the tenure of that customer is quite long with the company, then there is a huge long-term customer value that the customer is associated with, and losing that customer means not only raw loss, but then there is also a cost of acquiring a new customer in lieu of an existing customer. The current state, there is no score available, so there's no way in advance to know whether the customer who's trying to churn is a low value customer or a high value customer. So moving on to the defining the success of using the CRISP DM model. So the expected impact is reduce the customer churn and improve retention. The metrics associated with that from an outcome perspective, it's stemming the loss of having CLV. So in other words, maintain this revenue coming in from existing customers. Output is a mean square error of aggregate productions. And the targets are the outcome from a business plan standpoint would be reduction of loss of revenue by $10 million, and output is mean square error less than 0.3. The constraints we're going to be doing are predictions must be in risk categories of low, medium, high, and they need to be available to the agents. So the validation plan is about making sure we explain the plan, the solution to the potential users who are the agents, about 5,000 agents. The model will provide the risk score of each customer, 35 million customers, categorize each customer into low, medium, high risk category, and the design associated with the system. So there are several input features that are going to go in with labels and all that. So one of the things among the features on inputs would be a historical data about last 24 months of the payment data from the customer, along with any missed payments in the last 90 days, average monthly balance, average outstanding balance. All of those would be hyperparameters. And from a design perspective, this would be cloud-based because of the preferred over the edge, because of the huge computing power needed to process 35 million records on going through all of the 24 months of data. It's in several terabytes, and that could be effectively done using the cloud-based platform. And also, it's from a batch versus real time. This is going to be done initially on the batch too, so we have a baseline score, and then it will be further complemented with the real time for online production. The risks in production when it is rolled out is going to be there's possibly some drifts in terms of input data. So it's all going to be for existing customers, but it's this historical data. But for first time customers, there will be no risk available. So there's going to be some drift from an input data perspective. There will be some latency that might potentially creep in because of the large volume of customers being queried concurrently by the agents. There's a possible concept drift, but the model will be monitored for this. And potential issues that could likely be in product is agents may need to override some values, even though the model has accurately predicted, because of some edge case scenarios where they would need to have a better control of the scores. So that's in a nutshell, the ML project submission for Module 5. Thank you.